I studied AI in my undergrad and in my master's program, and I really enjoyed it academically, but I also realized that I spent a lot of my time actually at the product realization lab at my university, which is essentially the machine shop where you can learn things like laser cutting and 3D printing, and I realized that I actually am very interested in the hardware space as well. And I found that Normal was in this really unique intersection between AI and hardware, and I just wanted to learn a ton more about it.
In this era where the traditional paths to scaling, Moore's law and Denard scaling are breaking down, and we're getting a lot of wins out of kind of specialization in chips that are kind of unconventional, different, and narrowly tailored to different tasks. And so this is where I think that there's innovation in EDA that's required, not just to speed up what we're already doing, but to make it possible to actually design these new chips.
I think that it's important to really remember that the end user is just that design verification engineer who day to day is writing tons of stimulus and tons of test cases and just thinking what really is the thing that makes their life easier. Like I'll, in one day, be doing a sales demo, and then I'll be writing a spec for a new feature, and then I'll be working with the engineer on the evaluation of a certain feature, and then I'll be working with other PMs building out design mocks, and then I'll be working with some people on writing a blog post.
That's one of the things I really like about the discipline of AI is just how ruthlessly empirical it is. There's every week there's a bunch of beautiful and interesting ideas that are posted on Twitter, but at the end of the day, people say, well, show me the benchmark and we can test how well it works. And I think we have a kind of a core belief that every idea can be tested, it can be simulated, it can be benchmarked.
What really convinced me was the tape-out. I think that is a very tangible accomplishment. I don't really know if peers who have accomplished something similar in scope. It takes a level of complexity that you don't get at any kind of run-of-the-mill tech startup. And it felt obvious to me that this was the best time to join the company.
So you have the reviewability part where you see that they're able to actually understand how the collateral that's generated is tracking towards 100% functional coverage. But then you also have the fact that these tools themselves are very powerful standalone tools that do help them generate very interesting things that would have otherwise taken them on the order of months. And we can speed that up to on the order of minutes. And I think that when we go to these customers and show the product, that is a pretty jarring and exciting thing to watch, because it's in the same way as the software field where now we have these multi-purpose coding agents that generate thousands and thousands of lines of code in a matter of seconds. It's almost the same reaction that people are having here, where they're seeing a process that would have normally taken them months be done in front of them in a matter of minutes.
And another question I had is, where is there room for branches of physics like thermodynamics to make big contributions in the 21st century? Historically, the development of things like the steam engine and all kinds of engines, and then different branches of physics created a wealth of new technologies in the 19th and 20th century, and I think that we're also getting closer to getting an answer to that, which is that by bringing in thermodynamics and some of these theoretical ideas into the semiconductor industry, there seems to be some potential for a large impact there.
I feel like also one of these original questions that made me think of is, how can I surround myself with the people that would be excited to teach me about every part of the stack? And I think that as someone who maybe just started at the highest level of the stack working and studying AI, I think it was most important that people around me, when I get into the office, are telling me about how the intricacies of a memory chip work. And that was something I've never even thought to study or even was exposed to at anyway, or how these exact linear algebra paradigms allow for more energy efficiency gains. And that was something I've also never conceptualized. And I think just having people here who are invested in your intellectual growth and personal growth, and asking myself how can I constantly surround myself with those people, has led me basically to Normal.